Hey, welcome to Vtuber's Intro to Organic Chemistry. In today's video, we'll be talking about the nomenclature of alkanes. So what are alkanes? First, let's talk about what a hydrocarbon is. A hydrocarbon is a molecule consisting of only carbons and hydrogen atoms. For example, C4H10. In this molecule, you can see there's only carbon atoms and there's only hydrogen atoms. An alkane is a hydrocarbon consisting of only carbon-carbon and carbon-hydrogen bonds, and these bonds must be single bonds. I've written down here methyl, methylene, and methine groups and another line, but I would like to explain more about these terms at the blackboard. So here we are at the blackboard and we see there's a molecule over here, specifically an alkane. And these words or definitions I have over here are just systems and ways we classify carbon atoms. So let's start with the first system. A methyl group is a group of atoms where you have one carbon and three hydrogens attached to it. So in this molecule, we see, remember the 4-2-2-1 rule where carbon likes to form four bonds, and it's implied that hydrogens are attached to carbons whenever you don't see four bonds to carbons. So if I draw this out, this would be something like this. And we can see this would be a methyl group. And I'm gonna circle the other methyl groups, which is here, here, and here's a methyl group. So a methylene group is one carbon less. So it's bonded to, the carbon is bonded to different things, but it's also bonded to two hydrogens. And we can see methylene groups would be over here, over here, over here, and over here. Methine groups, again, one less carbon, would be this carbon, and would also be this carbon. In this system, we have no way of classifying carbons with four bonds to different things and no bonds to carbons. No bonds to hydrogens. So let's go down to the second system of classifying carbons, and where we classify carbons through the amount of CC bonds it has. For example, primary carbons have one carbon-carbon bond, which would be the methyl groups I was talking about. You can see, for example, this carbon is only bonded to one other carbon, so it would be a primary carbon. And everything circled in green would be a primary carbon. And secondary is similar to a methylene group. It's bonded to two carbons. For example, this one right here, this carbon, is bonded to two carbons only. That's why it would be a secondary. And tertiary, you can figure it out, is something similar to methine groups, where it's bonded to three separate carbon atoms. And finally, quaternary carbons are bonded to four different carbons. So for example, we can circle this one where it's bonded to four different carbon atoms. Alright, let's go back to the slides. Alright, so back here, let's move on to the next slide. So there are a few names you have to memorize over here. And again, we have to go back to the blackboard to talk more about this, but the name is based off the number of carbons you have, and for now let's just stick with basic straight line alkane chains, and the prefixes you have to remember are meth, F, prop, but, pent, hex, hept, oct, non, and dec. Notice how they all end with ane. That signifies that these are alkane molecules, specifically alkane chains. And for polygons, you just add a cyclo as prefix. I'll explain all of this at the blackboard. Alright, so we're back here. So let's just start off with the basic one, methane. Methane, so you have one carbon. So let's talk about the formula. So the typical formula to use for determining the formula of alkanes is CnHn+2. So for example, methane, you have one carbon, so N is 1, and hydrogen, let's see, 1 plus 2. Mistake, my bad. 2N plus 2. So you would have H4. So methane in this example would just be CH4. Ethane would have the formula C2, and 2 times 2 plus 2 is 6. So C2H6. And the drawing would be something like this, just a straight line. Propane would have C3H8. And the drawing would be something like this. And so on. I'm just gonna try to speed run this. C5H12, blah blah blah. 6 times 2, 12, 14. But you can see how the chain is getting longer and longer and longer. Okay, until you get to something like decane, which is like, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the formula, let's see, C10H, 2 times 10 is 20, plus 2 is 22. This would be the formula of a straight line decane alkane chain, whatever the way you want to call it. So let's go back to the slides. I might have forgotten to explain what cyclo meant, but I think the next slide might help, maybe. Right. So if you're working with polygons, so basically not straight lines, but like, you know, triangles, squares, pentagons, and octagons, you have to just name how many carbons you're working with. So prop, so that's 3 carbons. Add the ane, indicating that as an alkane you're working with, and cyclo, indicating it as a closed chain or polygon. So again, cyclopropane would look something like this. Cyclopentane will look something like this. Remember, pent means 5 carbons. Cyclohexane will look something like this. And we're going to be working a lot with cyclohexane in the coming lectures. And finally, let's talk about alkyl substituents. Remember, substituents are just attachments. Think of them as add-ons. For example, your limbs to your torso. And there are a lot of different groups. So again, let's go back to the blackboard. All right, so we're back here again, and get my paper. All right. So here are some substituents you might want to remember, because they'll be used a lot, and hopefully you can recognize them when you see them on paper. So a methyl group is simply just a CH3 group. So you have R, the rest of the molecule, attached to a CH3 group. An ethyl group is just one step further. Just 1, 2. So you're adding a C2H6 group, but typically you want to write it as this. Propyl group is a bit one more carbon, so something like this. You could add the prefix N propyl, and I'll show you why, because butyl groups, but you don't necessarily need to add it. Because there's another way of writing propyl groups as a substituent, which is isopropyl. You could write it as this, for example. Right? You still have 3 carbons, 1, 2, 3, and it's still an alkane substituent. So these are both propyl substituents, but in different forms. This is N-propyl, and this is isopropyl. And you also do like, again, polygon alkyl groups. For example, cyclobutyl group would look something like this. Oh wait, shit. Okay, here we go. That looks ugly, but yeah, you see what I mean. 1, 2, 3, 4 butyl, and it's closed, so it's cyclobutyl substituent. So for butyl groups, there's actually 4 different forms of it, and it gets quite complicated. So let's just go over them one by one. All right, so let's go with N-butyl. N-butyl, so the N here just indicate is a straight line. So rest of the molecule with 1, 2, 3, 4. So that's your N-butyl substituent. Isobutyl is R, this, and this. So 1, 2, 3, 4. You branch off at the second carbon. Sec-butyl, on the other hand, you branch off at the first carbon. So 1, 2, 3, 4. This is sec-butyl. And finally, terp-butyl, which is actually my favorite butyl, is dinosaur foot. Is it dinosaur foot or chicken foot? Whatever. But yeah, so these are the alkyl substituents that you might want to remember. And let's go back to the slides. So we're back here again, and that's all for today. Here are my socials, and the song is from my favorite ground pounding gremlin VTuber named Amelia Watson. This is her BGM for a loading screen. She's great, check her out. And finally, drink water, eat healthy, sleep 8 hours, exercise daily, and everything will be alright. Thank you for watching this video.